Good day. So I'm Engineer Paul Brian Siamagan again, and we are going to discuss hydroelectric power plant. So after we have discussed about the different types of turbines and how they work, okay, so we will now proceed with a hydroelectric power plant, which is the application of hydraulic turbines. Let us first define what is hydroelectricity. So ano ba yung tinatawag nating hydroelectricity? This is the electrical power produced by a hydroelectric plant through the use of the gravitational force of flowing or falling water. So, ibig sabihin, ito yung napoproduce or product ng pag-harness natin ng energy from flowing water. So, hydro means water, and electricity, of course, is the form of energy that is produced by harnessing the energy of a falling liquid, which is water. It is most widely used form of renewable energy, accounting for 16% of global electricity generation, 8,427 terawatt-hours of electricity production in 2010, and it's expected to increase about 3.1% each year for the 25 years. Okay? Since meron tayong different types of power plant, okay, so this hydroelectricity is produced by a certain power plant na tinatawag nating hydroelectric power plant. Instead na fuel ang ginagamit natin to produce electricity, we will be using the energy coming from a flowing liquid. Okay? So, paano ba natin nagagawa yung pagpuproduce ng electricity from a flowing liquid? Papasok yung tinatawag nating hydroelectric power plant. Okay? So, sabi natin kanina, pag sinabi natin electricity, okay, or power coming from a flowing liquid, which is water, yun yung tinatawag nating hydroelectric power. Okay? And yung hydroelectric power plant natin, siya yung setup na kinoconstruct natin to derive electrical energy from falling water. Okay? So they have, or power plants natin have different components. Makikita nyo yan dyan sa image natin. And one by one, we will be discussing those, okay, later on as we go on with the topic. What are the parts of hydroelectric power plant? So we have the reservoir. The reservoir is the storage of the headwater. When we say headwater, that is the water of the hydroelectric power plant that contains or possesses the potential energy, which later on be transferred or transformed into kinetic energy during the flow. Na yun yung hina-harness natin to create energy. Next is the dam. Okay? So yung dam yung construction to create a reservoir. Okay? Or to contain the water, to contain the headwater. Next, we have the intake. So dito pumapasok yung ating water sa intake and it is controlled by the control gates. Okay? So the control gates control the flow of water papunta dito sa ating penstock. So yung penstock naman, that is the channel, okay, kung saan nagpo-flow yung water natin from the reservoir going to the hydraulic turbine. So ito yung turbine natin. So the turbine, as we have discussed before, the turbine harnesses the flow energy of a certain liquid, or in this case, water. So yung turbine natin ang nagko-convert ng flow energy ng water into mechanical energy. Then the mechanical energy will then be converted into electrical energy by the means of our generator. So yung generator natin, siya yung nagta-transform ng mechanical energy into electrical energy. Then after nung electrical energy mo-produce ng generator, daan siya kay transformer na mag-change ng voltage ng ating electricity. So this powerhouse, siya yung nag-enclose ng ating transformer. And then from the transformer, dadaan sa mga power lines or transmission lines yung ating electricity for distribution sa community. Okay? And we have here the outflow. So yung outflow natin, so siya naman ang doon lumalabas or doon yung discharge ng ating liquid coming from the turbine. After na ma-harness natin yung flow energy ng water natin, it will be then discharged through the outflow. Minsan, yung outflow or yung outflow natin, yung water sa outflow, yun yung tinatawag nating tailwater. Okay? So, that is the end of the hydroelectric power plant. So, dun siya nagtatapos sa tailwater. Okay? So, the tailwater becomes or it flows papunta na doon, pabalik doon sa ating source ng water, which usually is a river or any bodies of water. Examples of hydroelectric power plants around the world. So we have first the Three Gorges Hydroelectric Power Plant, which is located in Yichang, Hubei province of China. Okay, so it has a capacity of 22.5 gigawatts. So yan, nasa picture, so ganyan siya kalaki. Then we have the Itaipu Hydroelectric Power Plant, which is located in Brazil and Paraguay border. Okay, and it is part of the Parana River, which has a capacity of 14 gigawatts. So, eto naman yung ating Itaipu Hydropower Plant. And then, we have the Sayano Shushenkaya Hydroelectric Power Plant, which is located in Russia. And it has a 6.4 gigawatt capacity. So, eto naman siya. And kung mapapansin nyo, those power plants are gigantic in construction. Okay? And usually, they are integral part of a certain body of water. Okay, kung saan nanggagaling yung ating mga flow energy. Ito naman, yung local hydroelectric power plant example. Okay, siyempre meron din tayong mga Pinoy. So we have the Ambuklao Hydroelectric Power Plant in Barangay Ambuklao, Bukod, Benguet, and it has a capacity of 105 megawatts. Okay? How much electricity can a hydroelectric power plant make? So, saan ba nagdidepende kung gaano kalaki or kung gaano karami ang electricity na mapoproduce ng isang hydroelectric power plant? So, first is how the water or how far the water falls. Kung gaano kataas, okay, or kalayo, nagpo-fall yung water natin. So, the farther the water falls, the more power it has. Generally, the distance that the water falls depends on the size of the dam, of course. So if the dam is smaller, so konti lang yung head natin. If it's higher, then it will have a greater head, di ba? For yung power natin, okay, yung power natin, di ba, is Q, di ba, gamma, and H. The Q is the volume flow rate, the gamma is the specific weight of the water, and H is the head developed by the water. Okay, if this H or the head, okay, is higher, then we have a higher power produced. Okay, so dyan nagdedepende kung gaano kalaki or kung gaano kalayo or kung gaano karami yung electricity na napoproduce ng ating hydroelectric power plant. Next is the amount of water falling. Alin ba yung amount ng water falling? So that is the volume flow rate. Okay, the amount, the volume. Okay, the amount of water available depends on the amount of water flowing down the river. More water flowing through the turbine will produce more power. Of course, this Q is directly proportional to our power. That's why if we have a greater volume flow rate or greater Q, then we have a greater power produced. So, dito sa dalawang to, nagdedepende kung gaano karaming electricity, how much electricity are we going to make in a certain hydroelectric power plant. So ngayon, we will be discussing about the types of hydroelectric power plants. Ano ba yung mga different types of hydroelectric power plants? Okay, so first is the impoundment. Okay, so when we say impoundment, it uses a dam, okay, as storage of water, okay, para magkaroon tayo ng potential energy, di ba? Sabi natin kanina, yung water natin sa storage or sa reservoirs, sila yung nagpo-possess ng potential energy, which will be transformed into kinetic energy during the flow, na yun yung kukunin ng ating turbine, and subsequently will produce electricity, okay, by the generator. Then we have the diversion. So the diversion, minsan tawag sa kanya is runoff river, facility channels, a portion of a river through a canal or penstock, okay, and may not require the use of a dam. So kung mapapansin nyo dun sa figure natin, okay, nandito yung diversion natin sa isang river, then yung flow ng water na yon yung gagamitin nila, okay, and yun yung kukunan natin ng energy ng turbine that will produce electricity. So, wala na silang kailangang dam. Okay? Kasi yung flow energy natin is natural from the river because a river is a flowing body of water. Okay? Then, we have a pumped storage power plant. It works like a battery. Okay? Storing the electricity generated by other power sources like solar, wind, and nuclear for later use. So itong pump storage power plant natin, okay, yung ating dito, meron tayong turbine, okay, which sometimes, okay, nagiging ano din siya, pump. Kapag hindi mataas yung demand for electricity, meron magiging pump yung role niya. Okay, ibig sabihin, yung water natin dito sa lower reservoir will be pumped up sa upper reservoir. Pero pag mataas na yung demand or kailangan na natin ng electricity, kailangan magpa-flow ulit tayo ng water pababa in which the turbine or yung machine natin dito na pump ay magiging turbine ngayon. Diba? Yung turbine natin, siya naman yung mag-extract ng energy na magpo-produce ng electricity. Okay? So, ito yung electricity na mapoproduce niya. So, kapag hindi masyadong mataas yung demand sa electricity, ito muna ay gagawin nating pump. Ang pump naman, okay, siya yung magpapataas ng water natin papunta sa upper reservoir. Okay? And kung kailangan na uli natin ng electricity, magpapababa uli tayo dito. So, ang gagawin natin, magiging turbine to. Okay? Then, it will harness electricity or harness energy from the flowing liquid and transform into electricity. Of course, the power produced by the turbine is greater than the power consumed by the pump. Okay? Para magkaroon tayo ng net electricity produced. So here are the sizes of hydroelectric power plants. Ano ba yung mga sizes ng hydroelectric power plants natin? So first, we have the large hydroelectric power plant. So these are power plants, okay, that has a capacity of more than 30 megawatts. Okay, we have the small hydropower plants which has a capacity of 100 kilowatts to 30 megawatts, and the micro hydropower plants, okay, which has the capacity of less than 100 kilowatts. Okay? So, yung micro hydropower, of course, ginagamit lang siya for domestic purposes. The large hydropower plants, of course, it is used for wide consumption, okay, or the first-hand source of electricity natin from hydropower plant, and yung small hydropower plant naman, siya naman yung nag-augment ng need ng large hydropower plant kapag masyadong mataas yung demand. So ano ba yung mga advantages ng hydroelectric power plant? So of course, it doesn't pollute the air like power plants that burns fuels kasi nga yung hydroelectric power plant naman natin, wala naman siyang harmful byproducts unlike dun sa coal or natural gas natin. So it relies on the water cycle which is driven by the sun. So it's a renewable power source. So yung water naman natin, renewable siya. Okay? Since meron tayong water cycle, mag-evaporate, tapos magko-condense, so paikot-ikot lang din. Okay? And it is generally available sa bodies of water. Okay? So ano yung mga disadvantages niya? First is the fish population impaction. Okay, ibig sabihin, 'di ba, yung large hydropower plant natin, okay, meron siyang nako-consume na parts of the bodies of water, okay, which is yung flora and fauna dun sa ating water. Tapos yung mga high velocity of water din, okay, medyo nagkakaroon siya ng effect dun sa habitat or natural habitat ng ating mga fishes. So it also impact the water quality and flow, okay? Yung quality ng water natin, yung dissolved oxygen niya, pwede niyang maapektuhan. And yung facilities, since nakita natin kanina kung gaano kalaki yung ating mga hydroelectric power plant, so it may compete with other uses for the land. Okay? So instead of a natural habitat, instead of a natural source or home for natural resources, so ginagawa natin, kino-construct natin siya ng mga kailangan natin sa hydroelectric power plant. So, nadidefeat yung purpose for as a natural habitat. Okay, so here are the useful formulas that we can use to identify or to know the parameters and the capacity of a certain power plant. So we will start with the gross head. So yung gross head natin is the head water elevation minus the tail water elevation. So that is the elevation of the highest point or highest surface of the water minus the elevation of the lowest surface of the water. Okay? The frictional head loss, since wala naman tayong ideal flow, so of course meron diyang mga losses, okay, energy losses due to friction. So we can use two equations. First is the Darcy's equation, which is HF is equal to FLV squared over 2GD. And the Morse equation, which is HF is equal to FLV squared to FLV squared over GD. So alin-alin yung mga variables. So F is the frictional coefficient, L is the length of the penstock, V is the velocity of the water, and D is the inner diameter of the penstock. Okay? So, ang Morse's equation for frictional head loss is equivalent to 4 times the Darcy's equation for frictional head loss. Okay? For the net head, ibig sabihin yung head na available, kasi binawas na natin yung gross head, okay? Binawas na natin sa gross head yung frictional head loss natin. So that is already our net head. So that is equivalent to Hg minus Hf, or the gross head minus the frictional head loss. Then we have the penstock efficiency. Alin ba yung penstock efficiency? So that is the net head, okay, over the gross head. Ibig sabihin, kung ilan yung na-harness natin or ilan yung available head compared dun sa gross head. Okay? So that will be the penstock efficiency. Ibig sabihin, if the penstock efficiency is low, ibig sabihin marami tayong frictional head loss. But if it's high, okay, kukunti lang yung frictional head loss natin. Next is the turbine efficiency. So this is already discussed before, okay, sa efficiency ng turbine and pump. So this is the brake power over the water power. Okay? So yung brake power natin is the power produced or harnessed by the turbine, and water power, of course, is the power produced by a flowing liquid. So the water power is Q gamma H still. Okay? The generator efficiency, okay, is the generator output over the brake power. So yung brake power na nilabas, okay, ni turbine, okay, yung brake power na output ni turbine will be the input, 'di ba? Ito yung output ni turbine, 'di ba? Okay? So that will be the input of the generator para mag-create siya ng generator output. 'Di ba? Kanina, okay, yung turbine natin, okay, mag-harness ng flow energy from the water, gagawing mechanical energy. Okay, yung mechanical energy, which is the brake power, okay, will now then be dadaan siya sa generator. Okay, siya naman yung input ni generator na mag-create ng generator output. Okay, so that will be our generator efficiency, yung output ng generator over the brake power. Okay, then we have the turbine output or the brake power iniba lang natin itong turbine efficiency. So, the water power, which is Q gamma H times the turbine efficiency. Okay? Tapos, the generator output is just equivalent to brake power, which is the turbine output. Ito, turbine output times the generator efficiency. Next is the generator speed. So the generator speed is 120 F over P. So the N is the speed of the generator, the F is the frequency. The frequency is, ang unit niya is in hertz. Okay? So hertz yung unit niya or cycles per second. Okay? And the P is the number of poles. So the number of poles must be even number, di ba? It should have north and south poles. So kailangan even. Then we have here the utilized head HW. So that is just the hydraulic efficiency of the turbine, okay, times the net head. So the hydraulic efficiency is 100% if it is not known or given. Okay? The head of the Pelton turbine or the impulse turbine. So sa pag-compute ng head ng Pelton turbine or impulse turbine, we have the P over gamma, the pressure over gamma, plus velocity squared over 2G. Kapag naman reaction turbine ng ating gagamitin, we have the Francis or the Kaplan. So our H or the head developed will be P over gamma plus VA squared, the velocity at the inlet squared minus the velocity at the outlet squared. Okay? Hindi siya quantity squared. Remember na ito ay VA squared minus VB squared. Okay? Hindi VA minus VB quantity squared. Okay? Over 2G plus Z. Okay? So Z, ito, is the distance of the center of the turbine from the surface of the tailwater. Kung ito yung turbine natin, okay, and ito yung tailwater, so yung center na to, okay, ito yung center ng turbine natin hanggang tailwater, that is the Z. Then we have here, continuation of the formula, the peripheral coefficient. So the peripheral coefficient phi or the turbine speed factor is equivalent to the peripheral velocity. So pi dn. So yan lang yung velocity ng periphery ng ating turbine over the velocity of jet na square root of 2gh. Yung square root of 2gh na to, okay, di ba? Sabi natin yung sa headwater natin, this is the headwater, this is potential energy. Tapos pupunta siya papunta dito kay turbine natin, di ba ito yung penstock, mag-flow siya papunta kay turbine, magiging kinetic energy. So if by the virtue of conservation of energy, if the potential energy will be purely transformed into kinetic energy. So potential energy natin is mgh equivalent to 1/2 mv squared. So, yung velocity ng jet dito, computing for V, okay? So, we have square root of 2gh. Okay? So, yan yung velocity natin bago siya mag-enter ng turbine. Kaya siya yung velocity ng jet natin. Ibig sabihin ng jet, so that is the water, okay, at a certain velocity. D is the diameter of the runner. N is the speed of the runner in RPM. Okay? Yun yung mga kailangan natin dito sa peripheral, sa peripheral coefficient. Okay? So, yan. So, yung G and H, alam na natin, G is the acceleration due to gravity and head developed. Okay? Then, the total efficiency of the turbine is just the product of the hydraulic efficiency, motor efficiency, and the volumetric efficiency. The mechanical efficiency, I mean, not the motor efficiency. Okay? So, the volumetric coefficient or the volumetric efficiency is the Q prime over Q. Alin ba yung Q prime? The actual volume of flow. Okay? And the theoretical volume of flow. So, ibig sabihin, ito yung computed flow natin. Ine-expect natin na flow. Kung ang actual volume is less than the theoretical volume, ibig sabihin, yung volumetric efficiency natin is lower. Ibig sabihin, may leak tayo during the flow. If it's higher, so may konting leak. If it's 100%, of course, wala tayong leak. Okay? So, ibig sabihin, hindi nababawasan yung nagpo-flow na water. For the specific speed of a hydraulic turbine, so we have here Ns is equal to N times square root of HP over H raised to the 5 over 4. So kapag English yung units natin, so yung N is RPM, the speed, Ns is always as well in RPM. Then head should be in feet. Okay? So yun yung formula natin. So same formula for SI units, okay, in which Ns is equal to 0.2623 times N times square root of HP over H raised to the 5 over 4. So kung mapapansin nyo, same lang si English and SI, meron lang tayong constant which is 0.2623. Okay, so that is just due to the conversion of different units from English to SI. So yung N natin is an RPM and head should be in meters when we are looking for the specific speed of the hydraulic turbine. Okay, so let's proceed with problem solving. So first, we have a hydroelectric power plant. We have a brake power, okay, which is equivalent to 1,800 kilowatts running at a speed of 450 RPM. Okay, and we have a net head of 30 meters. So we have to determine the specific speed. Ano ba yung specific speed formula? Ns is equal to 0.2623 times N, okay, times the square root of the power, brake power, okay, over the H raised to the 5 over 4. So the specific speed natin ngayon, we just have to plug in the values 0.2623 times N, which is the RPM or the running speed of 450 times the brake power of 1,800 kilowatts, okay, over H, which is 30 meters raised to the 5 over 4. So our specific speed Ns will be equivalent to 71.33 RPM. So this should be our final answer. For problem number 2, so we have a specific speed of the turbine is 75 RPM. Okay, so this is the specific speed of the turbine running at N, which is 450 RPM. We have head is equal to 20 meters and generator efficiency natin is equivalent to 0.90. So the maximum power delivered is being looked for. Okay? So, di ba? The generator output is equivalent to efficiency of the generator times the brake power. Yung brake power natin, makukuha natin sa Ns is equal to N times square root of the brake power over the H raised to the 5 over 4. Okay? So, para makuha natin yung brake power, gawin natin si Ns is 75 equivalent to 450 square root of the brake power over H, which is 20 meters, since meters yan, times natin ang 3.281 raised to 5 over 4. Okay, so the brake power now is equivalent to 968.92 horsepower. Okay, so the generator output is 968.92 horsepower times 0.9. So the generator output now is equivalent to 872.03 horsepower. So this should be our final answer.